So as we move on through project management, one of the triple constraints is time. And time is something we never have enough of. So some of the resource management concepts are we have constraints, limitations. How do we load our resources? What are the different techniques of when we actually use it? And how do we smooth it out? So the types of constraints are we can have technical constraints, we can have physical constraints, and we can have resource constraints. These are the things that limit our project. And so time is critical to all plans. What are the elements related to time? And what's the terminology in terms of how we schedule things in project management? So some of the project scheduling terminology. First, what is a network? And basically, a network is a collection of events, or nodes, as they're also called, and how they're related. A path is a sequence of activities defined by this network logic. An event is the beginning or the end. It's when it either starts or ends, and a node is just a point in a network, and it's a junction where it has to basically connect to something else. Predecessor, what comes before it? So the predecessor of B is A, the predecessor of C is B and E. What is a successor? What comes after it? So after E, it's C and end. F, its successor is G. The earliest start date is because since we have these ranges, and not only that, the timing of all events isn't going to always exactly match up. So the earliest start date refers to when is the earliest I can start without affecting the critical path. And also the latest start date is what's the latest I can get started without affecting the critical path. And the critical path is the longest path through the entire project. Now a lot of people get this wrong. A lot of professors professionals say, you're on the critical path. And they think that it means that you're on the riskiest path or the most difficult path. No, in project management, the critical path is just what takes the longest. A forward pass is when you do network calculations for an activity going through the network. Backward pass is when you look at it from the end going back. Merge activities are when things come together, like B and E come together as C. And burst activities are when you come off in a bunch of different parallel activities. So after you begin, it bursts out into ADF. Float is how much slack do you have? And so, for example, these two are taking place in parallel. This takes this long, this takes this long. So this guy, now, he doesn't have to start until here because he has to wait for this guy to finish. And so this is what's referred to as slack. Every project has some slack somewhere. And the reason why is if everything is perfectly tight and something goes wrong, then that's it. You've lost everything. And it becomes very complicated and everything else. So slack is a good thing. The critical path is the longest path. The critical path method is basically taking every pathway and calculating how long is it going to take. Now, here's a technique of figuring out if that node is on the critical path. And what it is how much slack does it have. And if the slack is 0, then then it's on the critical path. Because that's the point of the critical path. You are the longest path through it, so you can't have slack. If you have slack, then you're making the critical path longer than what it is. And there's also resource issues. Here's an example writing class project. First, identify the tasks for the work breakdown schedule. Determine what activities precede another. Determine that some activities do not have a precedent, and it can actually be done in parallel. And determine which activities require output from other activities to identify its predecessors and followers. So here's an example. this is the pathway for a term paper. Now, what if there's somebody who can help me and I could do something in parallel? So while somebody's writing the paper, I could put together the presentation. Now, as you can see, it's going to be a lot shorter and easier. And so, in terms of our terminology, each of these are nodes, these are pathways, and an event is what starts something or finishes something. And so, predecessors, successors, early start, late start. Now, these can start at different times. And so, depending on how long this is, odds are your presentation is going to take a lot less time than writing a paper. And so, this could have a late start. Or, maybe I want to early start this so this guy can go help this guy. And what it comes down to is the length of this is called a duration. And there are two ways of doing projects in terms of nomenclature. There's activities on arc, where you put the activity on the arc, or you could put activity on the node. And so activity on node is what MS Project and Project Libre typically use. Now you'll get so used to seeing this that you say, I gotta memorize this, but actually when you see it a lot, it's not too hard to remember. So this is the early start, this is the late start, so this means we could start as early as day 5 or as late as day 6. And here's the earliest finish, and here's the latest finish, and this is the duration, which is 5. Now, here's a little trick. Remember that the amount of slack on the critical path is 0? Here's a quick way to do it. Subtract the early start from the late start. If it's 0, then you know it's on the critical path, because that's what the slack is equal to. And if you notice, the slack is the same for early and late. In this case, it's 1. Here's some example. Microsoft Project will actually give you information about the nodes. Project Libre can also do the same thing. Gives you duration, the start and finish. Now, for a complete activity network, you have to go through the pathways. And the best way to do it is alphabetically, in a sense, meaning go like this way, AB. Okay, so I have ABE, I have ABD, and so each time something splits, then just keep it that way until you have every combination. The thing is, resource loading is, okay, based on the activity, how much work is everybody going to do? And so this determines how much you're going to pay. Like, what if you find out you have to pay overtime? Well, if I have slack, maybe I'm going to move that from one day to another day. Or what if I want to speed it up? Like, all of a sudden I have money. Well, then what you would do is start front-loading your resources. So you can use money to get yourself time. Maybe you make it longer so you can even it out so you don't have to pay overtime. So instead here you're using time to save you money. And so there are different things you can play off of. So here's an example of a chart with overallocation. So PERT is a technique we use to make estimates. Like, there's the middle case, the optimistic case, and the pessimistic case. And so based on these three estimates, how do you figure out what number you should use? And you use this handy-dandy formula where the middle case is 4, then plus the outside ones. And if you look at it, the coefficients all add up to 6, so you divide by 6. And so this gives you an expected duration, or average number. Now, in terms of charting this stuff, what Project does is gives you a Gantt chart. And so the Gantt chart is against time, and you can actually see where everything lines up. And also, what are the dependencies? Like, what has to happen before the next thing can happen? Now, again, you need slack, because you might be off. It gives you flexibility on how to do things. Murphy's Law, things can go wrong. Parkinson's Law, and that's that you tend to fill out the time if it's empty. And so Slack gives you that opportunity to do other things. And you can also have dynamic events, like maybe the price is changing on things, like inflation. So the critical path has no slack. Parallel doesn't add to the schedule, and that's how you do multitasking. Crashing is when you use resources to reduce time. And fast tracking means you put things in parallel instead of series to speed things up. And so our lecture on time is at a time.